Hello everyone, this is Sanjani. Today we are going to look at something really interesting, that is wideband FM transmitter in GNU Radio. But before we jump into the software, let's quickly understand what FM actually is. FM stands for frequency modulation. It is a way of sending sound, like a music or a voice, by changing the frequency of the radio signal. If you ever tuned your car radio to stations like 93.5 FM or 98.3 FM, that's exactly the same technology. The nice thing about FM is that it gives clearer sound, it reduces noise, and it works really well for music. That's why radio stations use something called wideband FM. Wideband simply means it uses more bandwidth to give better audio quality. So then what is this wideband FM transmitter? This is nothing but a type of modulation used by almost every FM radio station you listen to. A FM transmitter job is very simple. It takes an audio signal like your voice or music and convert it into a radio signal by changing the frequency of the carrier. Think of a carrier wave as a blank radio signal. When you speak into a microphone, your voice makes the frequency of this wave move slightly up and down. These tiny frequency shifts carry your audio information through the air. The wideband part means that the frequency moves over a larger range, which gives a better sound quality, especially for music. That's why FM radio sounds clearer and cleaner than AM radio. In our project here, instead of using a real audio, we are starting with two simple tones. These tones are acting like our demo audio signal, and the transmitter will modulate them exactly the same way it would modulate actual music or speech. So the concept remains the same. The transmitter looks at whatever audio you give it and tunes it into a frequency modulator radio signal that can be sent, saved, or visualized. All right, let's go through the block one by one in a simple and clear terms. First, signal sources. These blocks create two basic tone signal like two simple musical notes. These tones act like our audio input. Add block. The add block simply mixes both the tones together. So instead of two separate sounds, we get one combined audio signal. WBFM transmit block. This is the heart of the flow graph. The WBFM block takes the audio and convert it into an FM signal by changing the frequency based on the audio movement. When the audio gets louder or softer, the frequency shifts up and down. This gives us the fast changing FM waveform. Then we have resampler. This keeps the sample rate stable so that the whole system works smoothly. File sync. This saves the FM signal into a file. Display block. These GUI blocks shows us what's happening. Time domain represents how the signal changes over time, and the frequency domain represents how strong different frequencies are. Now let's quickly look at the output. So earlier we learned how to transmit a WBFM signal. Now let's talk about how we actually receive it. A WBFM receiver does something very simple. It takes the radio signal from the air, a signal whose frequency is changing all the time because of the FM modulation, and it turns those tiny changes back into sound. In simple words, the transmitter changes the frequency based on audio, and the receiver converts those frequency changes back into audio. That's all a WBFM receiver is doing. In our example, we are not using real antennas, we are using GNU radio blocks to stimulate receiving an FM signal, but the process is exactly the same as a real radio. Now let's look into the blocks inside the GNU Radio WBFM receiver. We start with a block that acts as a radio front end. It gives a wideband FM signal. This is basically a same signal we transmitted earlier. Next we have a WBFM receiver block. This is the heart of the system. It looks at the signal and flows the small frequency variation. Those variations are converted back into amplitude changes, which is basically our audio. Then we have some filtering blocks. These are used to remove noises, unwanted frequency, and keeping only a clean audio range. After that, the signal goes through a resampler. These blocks adjust the sample rate so that the final audio can be played properly on a speaker. And finally, we have a audio sync which simply plays the recovered audio. Now let's understand the output window.